For this first exercise of the chapter, we're going to build a simple calculator class. So we'll get started. Understand that this is going to be a very simple class and not something that I would consider a finished calculator program, but something certainly that you could build on and turn into a fairly decent program. So we have class calculator. We're only going to have one data member, and we don't really even need that, but we'll have a result data member that we can use to store the results of our calculations. We'll only have one constructor, and all it will do is set the result to 0. It's not really going to do much of anything. We don't need much in our constructor at this point. Then we'll have a series of methods that are based on the operations. So our first one will be add, which will take two operands. We will add the two operands together, store them in result, and then return the result. And you're probably thinking, yes, we could have just returned the result of adding the two operands together, but I want to go ahead and store the result. If we decide to build on this calculator, we'll need the result if we want to create more of a running calculator, where we store the result and then add another number to it or subtract or perform another operation. Now we're going to do the same thing for subtraction, multiplication, and division. Let's run through that very quickly. Result equals operand 1 minus operand 2. Return result. And then public double product. We won't say multiply. Product sounds better. Double operand 1, double operand 2. Result equals operand 1 times operand 2. Return result. And then finally, public double divide. Double operand 1, double operand 2. Result equals operand 1 divided by operand 2. Return result. And that's all we need for right now. So we'll close the class. Come into our main program. Call the constructor. We'll call our object calc equals new calculator. And then all we need here are a series of console write line statements. Calc add 1 and 1. Console write line calc subtract 12.2, 1.1. Product of 12 and 12. And then console write line calc divide 2.3 and 0.75. I've not extended this program to the extent that you could, and I'm not using it in a more interactive way. What I want to do at this point is kind of give you some things to build on by giving you a beginnings of a program and then letting you extend it and make something even better than what I'm showing you. What I've given you is essentially a way to create an object-oriented calculator. Now what I'd hope you would do is find a better way to turn this into a more workable program using some sort of interaction like a loop with prompts. The prompts would be stored where operand 1 and 2 go. Prompt the user for two numbers and an operator, and then call the correct operation based on that, just like we've done in the other versions of the calculator. But rather than show you all that and pretty much give it away, I want you to kind of use your imagination, take my basic idea, and turn it into something a little bit better. So let's run this program, and those all look correct. So there's an example of an object-oriented calculator. And like I just said, it's meant to be simple so that you can get creative and figure out some better ways to use it. Now we're going to move to the next exercise where we extend the time class and make it a little bit more useful and show a practical example or two. In this lesson, we're going to extend the time class by adding an equals method that allows us to compare two time objects to see if they hold the same time. Let me demonstrate to you why we have to do that. I create a time object called theTime. Then I create another object, same time, and I put the same data member values into the object. Now let's compare them. If theTime equals same time, console write line the same time, else console write line different time. And let's run this program. And we see that it says different time. Now why is that? That is because the equality operator does not know how to compare two objects of time class. To do that, we're going to have to write a method, an equals method or some other name. that allows that. So let me demonstrate how to do that. First, it's a public method because we want any user to have access to it. It's Boolean because it's going to return true, false. And we'll call it equals. The argument will be some time object. So we'll call it sometime because we're going to call this method with an object already selected and then bring in another time object to compare. You'll see what I mean in just a second. This method is just one if statement that says if hour equals sometime.hour and minute equals sometime.minute and second equals sometime.second, return true, else return false. We're comparing the current object's hour with the parameter's hour, the current object's minute with the parameter's minute, and the current object's second with the parameter's second. You can also use another keyword called this to signify the current object. Sometimes this makes your code just a little bit clearer, although it's not necessary at all. We'll go ahead and add it in. So now we can compare them. So rather than use this quality operator, we're going to say the time equals same time. And here we need another parenthesis. Let's see. The same time. We're comparing each data member of each class object. The current object represented by this and the parameter object represented by sometime. There's much more you can do with classes and extending them in lots of ways. One thing we didn't do, but we will in later lessons, is actually do something with the time object, actually time something. That's one thing you can do with the time object, or you can use it to note an appointment book or something. But I thought it was very important to demonstrate what happens when you try to use built-in operators with class objects. I decided to extend time class with the equals method for this exercise. And that wraps up the exercises for this chapter. And now we're ready to move on to the next topic in object-oriented programming, and that's inheritance, where we learn how to reuse definitions from a superclass in a subclass. For example, a car is a subclass of vehicles, and a convertible is a subclass of car. But in inheritance, we can define some characteristics of a vehicle and then extend those into the definition of a convertible. And I'll demonstrate how that works in the next chapter.